We are the team HackTheBox, and we are proud to present our SwasthyaSetu AI, an AI-powered platform designed to enable accessible and scalable early Alzheimer screening for Bharat. Early detection of neurological diseases can significantly improve the treatment outcomes, but current screening methods are often expensive, time-consuming, and inaccessible for the large part of the population. As we discussed it, like the early detection of the neurological diseases, that is very hard. And to achieve that, it is a very significant outcome which will help to treatment, which will help directly to the treatment outcome. So, Swasthya Setu AI addresses this challenge by combining machine learning models, cognitive assessments, cloud-based infrastructure, and at the end, with the help of Gen AI, to create a digital platform for early risk prediction for the Alzheimer disease. So, as we selected the problem statement from the student track, which was AI for the communities and access and the public impact, which we named it as undeserved Indian communities struggle with healthcare access due to the late detection of the critical diseases. So we have taken an example of a Alzheimer disease, like our project is scope for the multiple disease. For the example, we have took Alzheimer disease. Alzheimer disease is one of the fastest growing neurological disease disorders worldwide. However, in India, early screening tools are very limited. Clinical testing is very expensive, so the rural population lack to have a specialist access. Diagnosis often happen very late. What to do if the diagnosis happen very late and with directly in the stage of stage 2 or stage 3? The recovery from that stages are very difficult and it could cause to a direct death or loss of the life. So, early detection is critical because it allows a preventive care, early treatment, slowing the disease progression. With the help of early detection, we cannot stop or we can prevent the disease from the dynamic progression like it the way it needs to be progressed. We can have a early treatment and the preventive care. So, what are solution? The solution overview would be like that. Swasthya Setu AI provides an AI-powered multimodal screening by combining the major inputs like clinical profile detail, cognitive test responses, neuroimaging, MRI analysis. These inputs are processed and using on the machine learning models deployed on the AWS to generate a risk prediction score for the Alzheimer detection. This creates a digital screening tool for the early neurological assessment. Now, I have explained you all the problem statement and what is the solution overview. Let me give you a demo for of my architecture, how the data request will be flow from user to the end of the whole architecture. Let's us have a deep dive in the architecture. So this is our architecture, Swasthya Setu AWS serverless architecture. So our architecture is divided into the multiple layers like client layer, API layer, databases layer, and the essential services which I have kept on the right side, security identity, voice service, management service. So our system uses a fully serverless AWS architecture, ensuring scalability, reliability, and minimal operational overhead. The architecture consists of four layers. Let us go with the first layer, that is client layer. So in client layer, in this way, the user will directly react with the client layer. The request will be served with the CloudFront, and the S3 is holding our React web app. The front end is a React web app application distributed globally using Amazon CloudFront for the fast content delivery. Now we go with the API layer. What will the API layer do? User requests are routed through the Amazon API gateway. This component will gateway, which will securely explore our backend services. API triggers API gateway triggers AWS Lambda to handle the functions inside it. Alzheimer prediction interface, which I have used with the Docker model I've used to make this Alzheimer prediction model, and assessment data processing, which will have all the assessment of the get and save assessments, and the transcribe handler, which will use to handle our transcribe service. Like means it will do like that. If we speak whole the text, it will extract the required text and the required information from this by using a lambda function. The transcribe will convert the speech to text, then the essential text would be extracted through lambda. Do you think why we have chosen Lambda? We have chosen the Lambda because it is an event-driven, automatically scalable, eliminates the server requirement. Server management, or I can say AI processing. The Alzheimer prediction model run inside an environment using Docker, ensuring portability and consistency of ML inference. The system also integrates AWS Transcribe, like I have said you, for voice processing, where cognitive test maybe include voice processing. Database layer. Now we have used the DynamoDB As all user assessment results are stored in the DynamoDB, a NoSQL database, a serverless NoSQL database from my side. We have selected DynamoDB because why we have selected DynamoDB? We have selected it for automatic scaling, low latency, and serverless management, which makes it very ideal for a AI submission metadata and a user assessment storage. The another service which I have used is like monitoring, which is like CloudWatch log metrics. We have used CloudWatch to track our logs, monitoring health system, and ensure operational reliability. As we have also used the Amazon Cognito user pool login sign up JWT. This provides you a security and the identity, which means the user first will be, if it is a new user, he or she will have to create an account and it will be verified using the Amazon Cognito service. Then only he can have our assessment services. Why we have used all these services? For example, each AWS service was chosen intentionally, not to just randomly, to optimize the scalability and the development speed. Lambda was chosen instead of EC2 because Lambda removes the need for the server management, automatically scales with the demand, making it perfect for the prototype and AI inference APIs. Why we have selected DynamoDB? DynamoDB was selected instead of traditional SQL database because our application requires a fast read and write accesses for the user assessments. Rather than a complex relational queries, DynamoDB was better serverless fit than RDS. CloudFront is hosting directly. CloudFront provides a global CDN distribution, improving latency across the globe. Docker model, Docker for ML model deployment. Docker ensure the consistent environment and across development production, avoiding the dependency issues during model inference. AWS Transcribe, this is also service we have discussed. This enable the speech to text conversion, cognitive voice based test, enabling the accessibility for the user who may prefer a voice input. Now we have known the whole architecture. Now let's go with a demo. The demo of our SwasthyaSetu AI, which is a solution for the detection of early detection of the AI of Alzheimer. Now, first of all, when we get to that page, the land page with the home page of our whole Swasthya Setu AI, first off, if we are a new user, we have to get login. Let's go and log in our, let's, we have to go with the create account. We don't have an account, so we have to create one. So I will use one my test email. Let me check that proper username. It would be like, okay, so let's go with this. Okay, now I have to create a password for this. I'll click register. So verification code is sent to our mail. This was the whole services which are managed by Amazon Cognito. So let's go and get the verification code. Your verification code is here. We'll just copy this and paste it. Boom, we are verified. Now we have to log in it again. So let's go. Now, so yeah, we have login and this is my account as we can see which user is this. And so the when the user lands to the land page, now he or she can have an assessment of his Alzheimer disease. Okay, let's go with Alzheimer disease. Now these are the multiple fields which we have to fill accordingly our clinical history. And so with the help of this, we can detect whether the Alzheimer. Now let me fill my details like age, which is 21. Gender, I will select male. Ethnicity for these are all the terms which will be detailed in the introduction in the README, and educational level, which high, BMI I can keep 26, smoking, which will be 0, and alcohol consumption, moderate, physical activity, which we can go with moderate, and diet quality, average. Okay, so sleep quality, which is average, family history, no, cardiovascular history, no. So as all the details I am filling, you can see that diabetes, no, depression, no, and the head injury, we can go with no. So hypertension, we can give it one. Systolic diabetes, I am having near about 128, and that would be 190. Cholesterol, yeah, moderate cholesterol. Cholesterol LDL 100, and the cholesterol it would be 55, and triglycerides would be 160. And MSME, I can keep it at around 25. Functional assessment missed. It would keep it one. So let me go with this first. Okay. Now we have the memory complaints like 0, No, with zero and the behavioral patterns zero and ADL zero. Okay, confusion zero, disorder zero, personality changes yes, and difficulty zero. Forgetfulness, 0. And Nocturne charge, 1. Now I have filled all the details and I have also provided an option. We have also provided an option for the tab to speak while the user can have a tab to speak and our transcribe will contain all the script which is spoken by the human. Then it will be extracted by the transcribe service to extract. It will be converted to text. Then automatically with the help of AI, our AI, it will be filled in this all fields. Now let's go with the whole run final analysis. So this analysis will tell us the prediction. Oh, so yeah, I am not having Alzheimer. So risk level is very low. Prediction no Alzheimer's. Reliability, probability score with 0.29 and risk classification low. So I can also download a report from here, like it is downloaded in the form of yeah, this downloaded, and we can find a nearest PHC. So I can go with this. I can find a nearest PHC, which will directly locate me to the nearest health centers from where I can get the help. This will the whole map is which will be loaded. This is the whole map which is loading. As you can see, the whole map as my location are also detected from here. As all this. So this was a whole, and we can go with the assessment history. Now let's go with the what happened in the all AWS. Like I have done the risk level low. This is all my. I can also have a new assessment. No Alzheimer probability was this. Risk level very low, and I can also go with the view details. PHC finder, which will locate you to open nearby PHCs. Now let's go to the AWS. As we have like I have a demo with the Cognito also. We can also see the Cognito. The new user was created like Pintu Gurlani 1313. So the entry will be in that also, and the Amazon DynamoDB will also contain some entry. So let me go with Amazon DynamoDB also, or I can search with for DynamoDB. I've gone with DynamoDB. DynamoDB console is opening. As we can go and move for other tables which we have already. I think I would having a region in Mumbai specific. So yeah, boom. I've seen. We have the tables here, and all the table which are produced are here, and auto like this is my table, which will consist of all the records which are generated here. So we can see the table and the all table and start scan. 17 items which are scanned and updated at this explore table items also we have seen like yeah all the data compares from here like we have seen the last was the Pintu Gulani 1313 which we have done at 26 2026 features were this prediction was low how much was the all the probability score as the whole table can we can see from here and this can also perform the multiple features and this was the my DynamoDB entry. Now I can also show you with the Amazon Cognito that my user is also verified incognito. Let's go with cognito. It's loading. It will be directed here. So yes, again I have to change the region. It would be Mumbai because I have the nearest region Mumbai. So I've kept that and to make the all services to very fast, like user pool, which is all the maintaining estimated number of users for here. Users you can see from here. Like these were the all the user which are confirmed and signing authentication methods and all will be like we can search for the Pinto Gulani. Yes, it is confirmed. We can go for the more details of the Pinto Gulani as we have gone here. Created time was this, last updated time. It will contain all the we can say the features of the particular email. So as I have discussed in the architecture, we have seen the services like my data flowing from the Cognito, then to the first our user, like I was the user, I have interacted with the client layer API gateway has done my Alzheimer prediction assessments were saved and I can also use the voice service to have this transcribe feature. Then it was all saved in the DynamoDB and the user identity security was done by the from we can say Cognito feature. Now let us discuss the what we can say the cost efficiency for this. Our architecture is optimized cost efficiency using serverless infrastructure, Lambda functions that scale from zero to we can see the any expense where the requests are there. DynamoDB have a serverless billing model, CloudFront for caching and reducing the backend load, and these and the other services like free tier. Mostly services are of the free tier for many AWS services. This allows the SwasthyaSetu AI to run extremely low at the operational cost, making it very feasible. Like we can also have a discussion about what was the business impact. The business impact beyond being a prototype, Swasthya Setu has a strong real world impact and business potential. Like neurological diseases like Alzheimer's are growing rapidly in India due to the population and the lifestyle changes. However, early screening tools are remain limited to the specialized hospitals. Means most of the hospitals have do not have this early screening. They are only to the specialized hospitals which the rural population and the other population can also not access because due to their very expensive nature. So hospitals and diagnostic lab can integrate the platform, AI-assisted screening tool. Rural clinics and health workers can use it to early detect before referring to patient for specialists. From business perspective, the platform can follow as a software as a service model where the healthcare provider subscriber to the screening services. Uh, One more metric, like if deployed at scale, the Swasthya Setu AI could enable 1 million of early screening annually, help to detect neurological risk before the traditional diagnosis. So, to conclude, Swasthya Setu AI demonstrate how the AI and the cloud technologies can transform early disease detection and make advanced healthcare by available the screening accessible to everyone. By leveraging ML and AWS infrastructure with help of AI, we aim to build a scalable platform which is capable of supporting the millions of the requests for the health screening across the India. So, we the team Hack the Box and this Swasthya Setu AI, our vision is to move healthcare from reactive treatment to proactive AI powered early detection. So, the all the future scope would be like the all the upcoming phases, disease like tuberculosis, pneumonia, and all. So, to conclude the with the final statement, it would be like our vision is to move the healthcare from a reactive treatment to a proactive AI powered early detection. Thank you from Hack the Box.